Just as we perform pre-lab measurements to test the theory and soundness of our experiments, testing the LabVIEW code with the power distribution unit requires a few preliminary steps. The first of these regards the 5-switch load box, which acts as a small-scale forward operating base simulator. We must measure the resistances associated with each switch, and with these resistances, calculate the associated load. This can be done using power equals voltage squared over resistance, assuming the voltage provided is 120 volts RMS. The second preliminary step is to set up a test plan to evaluate the iterative load balancing solution provided by LabVIEW. Using the measured loads of the switch box, we can set up an unevenly balanced initial situation across the 3 phases of the PDU. The PDU has 6 sets of outlets, with one permanently tied to each phase and the other with the ability to switch the respective load to a different phase. As you can see on the PDU, the outlets marked by a strip of electrical tape above them have the ability to switch. The test was designed so that the balanced solution would place a roughly 180 watt load across each phase, but start with an initially unbalanced situation with the loads on each phase ranging from roughly 90 watts to 270 watts. For simplicity's sake, only one load was placed on a switchable outlet, but the proper switching of this load would be capable of producing a balanced solution. The final step of this pre-lab was correctly hooking up each of the loads to their respective outlets, safely providing power to the PDU by the Hamden machine, and connecting the National Instruments data acquisition card located in the PDU to the main computer. Safety considerations to keep in mind during the testing process are to have an advisor inspect the setup before turning on the Hamden machine, covering the PDU with its lid while it's powered, and introducing the loads to the system slowly to avoid transient surges in power. With the setup complete, the first step in testing was to run the load summation probe in LabVIEW and recording the measurements for real power across each phase. By recording our data in Excel, it is possible to compare the predicted power measurements with the actual measurements for each state. The most balanced solution should then have the least variance across all 3 phases, or more generally, ensure that each phase is within 20% of the others by our definition of balanced. This concludes the LabVIEW test plan. The current LabVIEW code does not finish on a balanced solution after iterating through each state, and does not iterate more than once to ensure that it is selecting the optimized solution. The end state for Project A will remedy this problem.